Right, this is AP Review. We're doing 2010 Form B, AB for response 6. Two particles move along the x-axis for the window between t equals 0 and 6 inclusive. The position of particle P at time t is given by P of t equals 2 cosine the quantity pi over 4 times t, while the position of particle R at time t is given by R of t equals t cubed minus 6t squared plus 9t plus 3. So both of these are positions, right? Two separate particles, both are positions. Part A, for that window from 0 to 6, find all times t during which particle R is moving right. So this is going to be a lot about translation in this problem, right? So in part A, right, we should make sure we note what they ask, right? So they ask, when is R moving to the right? Okay, that's what they're asking. So we need to translate that to what it means as a definition, right? So R is moving to the right if its velocity, meaning R prime of t, is positive. So that's what we're looking for. We're looking for where R prime of t is greater than 0. And if we know that, then we go ahead and find R prime, and we're going to figure out where R prime of t is greater than 0. So then I need to do some math, right? So my R prime of t should be a 3t squared minus 12t plus 9. Right? That is a GCF of 3, which I'm going to yank out and get a t squared minus 4t plus 3. So I get a 3 times a t minus 1 times a t minus 3, because factoring is totally dope and really important. So I need to find those values where R prime is 0. So R prime equals 0 either when 3 equals 0, which is a lie, or when t minus 1 is 0, so that's at t is 1, or when t minus 3 is 0, which is when t is 3. Now, there's two easy ways to do this. You can either make a full-on sign chart, or you can recognize that R prime is a parabola that opens upward, right? It's a smile, because it's a t squared, right, which makes it a quadratic, right? So it's a t squared, makes it quadratic, and the positive 3 in front makes it a smile. So if you know that it has zeros at 1 and 3, it looks like this. So since you want where R prime is greater than 0, it's going to be these windows here, but because you have endpoints, because we're from 0 to 6, my answer is going to be from 0 to 1, but it's not going to include 1 because at 1 it's actually at rest, and from 3 until 6. It's going to include the 0 and the 6, but it's not going to include, it's because the particle was actually moving right at the start, and it was actually moving right at the end. The AP doesn't agree with me about the brackets, but we can have a fight about it. I disagree with the AP. These two should have brackets because the particle starts at the beginning, moving right the instant the problem starts. Cool. Part B. For that same window from 0 to 6 inclusive, find all times t during which the two particles are traveling in opposite directions. Okay, so we already have a sign chart for R, right? So we already know that this is my R prime, right? So we know that R was moving right and then left and then right again, right? Starting at 0 and ending at 6. So now we just need to make a sign chart for P prime and figure out which way P is moving, and then we can answer the question pretty easily. So I'm basically going to do the same stuff that I just did for R, right? But I'm going to do it for P. So I'm going to keep this in case we need it, because we should need it if everything goes all right. But let's do the same stuff for P. So for part B, we're basically going to do the same task as A, but with P prime of t, right? Not R prime of t, and then compare to that A that we did, right? Compare to that sign chart that we had from A. So P prime of t, right? My P is going to be, derivative of cosine is negative sine, and then I'm going to have to do the chain rule in times by that pi over 4. So I'm going to get a 2 times a pi over 4, right, which would be a pi over 2, and it should be a negative sign. So I should get negative pi over 2 times the sine of pi over 4t, right? So I need to find the places where this is equal to 0. So 0 equals negative pi over 2 sine of pi over 4 times t, right? So either negative pi over 2 is 0, which is a lie, right? Those are both numbers and they are not the same number. Or the sine of pi over 4t equals 0. Well, sine is the y value on the unit circle, so I usually use y sub uc to make it clear that I'm talking about the unit circle. So sine is 0 at all the pi's. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So in order to make sure, and I'm actually gonna erase my R stuff, and we'll come back to it, and I'll just redraw it if I have to. So in order to find these values, I need to set this angle, which is pi over 4 times t, equal to 0, pi, 2 pi, 3 pi, 4 pi, right? I'm going to do a couple of them, right, and see how far I have to go, but I want to make sure I hit all of the ones in the window from 0 to 6. So pi over 4t is going to equal 0 and pi and 2 pi and 3 pi. And the reason I'm not worrying about the negative pi's, even though I could, technically, right, I'm not worrying about the negative pi's because I know that my window starts at 0, right? So when I go to solve, I times everybody, this whole bunch of things, by a 4 over pi, right? And what's going to happen is all the pi's are going to cancel, and I'm going to get that t is 0, 4, 8, and then I notice that I don't even have to go, I could keep going, but it's a 12 and a 16, and I don't need them because they're all past the window. So it turns out that the only two zeros for this function in this window from 0 to 6 are 0 and 4, and that's the only two possible zeros, right? So now let's make a little p prime sign chart, right? So p prime is a negative pi over 2, which does need to show up on my sign chart, times this sine of pi over 4t, right? It starts at 0, it has a critical number at 4, and it ends at 6, right? There's nothing after 6, there was nothing before 0, right? So, so my p prime, I can use this sign chart to figure out the net value. So I know that negative pi over 2 is always negative because it's like a negative 1.5-ish. It's not really a negative 1.5, but when you're thinking in a pinch, you could call pi a 3-ish, and you're not wrong. I know this guy's 0 here and here, right? So the easiest thing to do is just plug in a number, right? If you're not sure what to do, plug in a 3. Sine of 3 pi over 4, if you were trying to think where 3 pi over 4 is, that's right here. That's a positive, right? Try plugging in a 5 here. That's sine of 5 pi over 4, right? If you try plugging in a sine of 5 pi over 4, that's right here. That's in quadrant 3. That's a negative. So what's going to happen is your p prime is negative and then positive, right? Meaning that p is moving left and then moving right. So now, if you want, we can compare those results to the results that we had in part A. So I'm going to buy myself a little bit of space. Again, one of the hazards here is that I have to keep erasing some of my work, but fingers crossed we get it right. So let's think about what we know about r prime and what we know about p prime, right? So we know they both start at 0, right? If you recall, r prime had critical numbers at 1 and at 3, right? So I'm going to go ahead and put 1 and 3, and this had critical number at 4, and then the end point of the problem was at 6, right? So r was 0 at 1 and 3, and because it's a parabola that looks like this, it was positive and then negative and then positive thereafter, right? P prime had a 0 at 4 and 0, and we've established that between 0 and 4 it was negative the whole time. My bad. Negative, negative, negative. And then from 4 to 6 it's positive. Now, those are the signs, right? So that's left and right motion, right? So when these signs are the same, those are the moments when the particles are moving in the same directions. When these signs are opposite, they're moving in the opposite direction. So when r prime is positive but p prime is negative, that's one of the answers. When r prime is positive but p prime is negative, that's the other answer. So they are moving in opposite directions, right? They are moving in opposite directions on the window from 0 to 1 and on the window from 3 to 4. And that's my answer, right? Cool. Part C. Find the acceleration of particle P at time t equals 3. Is particle P speeding up, slowing down, or neither at this time? Explain your reasoning. Okay, so let's do the first thing they asked first, because even if you panic and don't know how to do something else, you can do the first bit. So we already know that P of t is 2 cosine of pi over 4t, right? And we know that P prime of t, right, which would be the velocity, right? So this was position. This is velocity, right? We already found this to be negative pi over 2 sine of pi over 4t, right? So p double prime of t is going to be my acceleration, right? So derivative of sine is a regular cosine, so the sine's not going to change. And I'm going to have to times by pi over 4. So this is going to end up being a negative pi over 2 times that pi over 4 for the chain rule times the cosine of pi over 4t. Right? So this is going to be the acceleration. They asked you specifically for the acceleration at 3. So it's going to be p double prime of 3, which is going to be a negative pi squared over an 8, right? Times the cosine of 3 pi over 4, right? Well, 3 pi over 4 is right here on the unit circle. That's going to be a negative root 2 over 2. So your answer is going to end up being a pi squared over 8 times a root 2 over 2. And you could simplify that if you want, right? It's up to you, right? So you could, I don't know, it's not a whole lot that you can just simplify it. I'd probably just keep it like that. You could make it a 16 if you want on the bottom. Okay, so that's the acceleration, right? That's the acceleration. They then ask you speeding up or slowing down. So a quick reminder of what that question is. Speeding up means that your acceleration and velocity have the same sign. Slowing down means that they have opposite signs. So again, acceleration and velocity have the same sign is how you're speeding up, either if both of them are positive, which is fairly intuitive, or if they're both negative. Like if you jump out of a plane, you have a negative acceleration due to gravity, and you also have a negative velocity, so you're speeding up as you hurtle to your death. If you're driving towards a yellow light, you're moving forward, that's positive velocity, and you hit the gas pedal, that's an acceleration that's positive, you are speeding up. So you either hear that as speed increasing or speeding up. Speed decreasing or slowing down is when either of them is the opposite sign from the other one. So, for instance, if I'm driving towards a yellow light, my velocity is positive, but I put the brake on because I see the yellow light and I want to be responsible. Well, now my velocity is positive, but my acceleration is negative. I'm slowing down. Or if I jump out of that plane and I open a chute, my velocity is still negative. I never stop moving downward, but my acceleration, because of the drag of the chute, becomes positive and I slow down. Anyway, so moving on. So essentially the question they're asking me is find p prime of 3 and then compare the signs. So if I look at my velocity, p prime of 3 is going to be a negative pi over 2 times the sine of 3 pi over 4, right? That's going to be a negative pi over 2 times a root 2 over 2, right? This one's negative, right? This one is a positive number because those are all positives. So to use their wording to answer the question, the particle is slowing down, so particle P is slowing down. And again, if they had said speed decreasing, use that language, right? Use the language they use, because P prime of 3 and P double prime of 3, oh, one of them is a regular prime, one of them is a double, of 3 have opposite signs. Right? Or you could say because the velocity and acceleration have opposite signs at 3, but either way you communicate it is fine. But the reason is because there are opposite signs. Cool. Part D. Write but do not evaluate an expression for the average distance between the two particles on the interval. Okay, so if you want to find the distance between the two particles, right? So it doesn't matter which one you subtract from the other. If you're so they're both moving horizontally, right? If you want to know how far apart they are, you would subtract one position minus the other. It doesn't matter which one you subtract, because to find their distance, you're going to make it an absolute value. So the distance between them is either p of t minus r of t in an absolute value, or if you like it better, r of t minus p of t in an absolute value. It doesn't matter. Either of those. So if you want the average value of anything, right, so this is part D, right? If you want the average value of a function, any function, right, you do that by integrating the function and dividing by the width of the interval. So the average value of a function in general is 1 over b minus a, the integral from a to b of f of x dx, right? Well, this is my function, or this one, it doesn't matter which one you pick. So the average distance between them is going to be they said 0 to 6. No, they said 0 to 3. Or, yikes, 1 to 3. Sorry. Average distance on the window from 1 to 3, whew, they almost got me there with the 0 to 6, is going to be 1 over 3 minus 1 times the integral from 1 to 3 of, and then again, whichever of these distance ones you picked, right? It doesn't matter, right? It doesn't matter if you did p of t minus r of t minus p of t, because they're in an absolute value. And that's fine, right? If you want to change the 1 over 3 minus 1 into a 1/2, that's fine. If you don't, that's also fine.